Good afternoon, students. Myself, Basraj Patil from Physics Department. So now we'll start the actual syllabus of first year, right? I will start from units and measurements. Units and measurements. Though in the first part of your physics, you will find the physical world as the first chapter actually, but that physical world after some after chapter completion of first chapter or second chapter, will again take that first chapter physical world. Now presently I am starting now second chapter of first part of physics book, first part of physics, second chapter, that is units and measurements, right? Okay, right. So now we'll start units and measurements. Done? Okay. Let me go here. Units and measurements. Units and measurement, right? Okay. See, in the physics progress, in the development of physics, measurement plays a very fundamental role. So without measurement, the physics cannot be completed. Let me, you can have an example. Like if I take a natural phenomena, suppose an object is falling. Suppose an object is falling. So everybody can tell the speed of that object falling will increase because of that gravity. Okay, if suppose an object is dropped, like an object is dropped, as it moves down, its speed increases. Everybody can say speed increases. Thing is that in physics, so we want how much increase in every second we want number in physics. We want number in physics. Physics, completely depends on measurement. So as you know, if suppose an object is falling, definitely speed is increasing. But thing is that later on with the help of physics, now presently we will be knowing that acceleration due to gravity is what? 9.8 9.8 meter per second increase in the speed in every second. We know it. What is the meaning here? 9.8 meter per second increase in speed in every 1 second. Right or not? So this we know it, acceleration due to gravity is 9.8 meter per second square. We can tell only body are falling. If it is increasing its speed, we say it's incomplete. Physics require number. Physics require number. Right or not? Physics is a exact science. It like theory type everything doesn't work out. We have to measure to verify any phenomena. We have to measure. So here I told you, so G value with the help of physics, we will be knowing that 9.8 meter per second square. Its meaning is in every second the body falling, speed increases 9.8 meter per second in every second. Just one example I told you. Like, so in physics, we want number, how much, exact value. Then only the study of physics will complete. Whatever you take, so nowadays, the in the process of measurement, the accuracies has increased now nowadays because of development in the technology, where we have developed very accurately measuring devices, right? Okay, so we tell you, so if you know 1 second law, like, so force is directly proportional to rate of change of momentum, you can tell. So how do you practically verify? Only sentences, only theory doesn't work out in physics. We need to back up that theory with practical. Like, this is the formula you already learnt in. This is a formula you already learnt in. Okay, in Newton's second law. So this formula, like the measurement of force, measurement of mass, measurement of acceleration, we can, by measuring this quantity, we can back up, we can verify, we can prove, okay, Newton's second law theory and its practical are synonym, they are same. Any statement, any law, any theory, it should be backed up by practical measurement. Like this equation is a Newton's second law. We know theory of, that law, Newton's second law, we know it. That Newton's second law, you want to back up, you just, you want to justify that Newton's second law, whatever it says, practically it's okay. This is the representation of Newton's second law. So with this, we can say Newton's second law is okay, right or not? So whichever part of physics you go, measurement becomes a fundamental part of physics. Getting my point? That's the reason. Whatever, like whichever physical quantity or whichever law in the physics you consider, definitely you might, some thoughts there might, you might, some thoughts might be floating. Everywhere measurement is required. Okay, especially in physics, right? Okay, it may be a measurement of size of mass, it may be a measurement of size of the room, or whatever, like, many cases where in physics, so measurement becomes very fundamental, right? Okay, so with that introduction, the importance of measurement in the learning of physics, now very first chapter I'm taking now here, units and measurement, right? Okay, now one more thing I would like to remind you. So because of the measurement nowadays has been, accuracy of measurement has been developed very, accurately. The development has become, the measurement, accuracy of measurement has reached such a peak that you can say, you can even measure the indirectly, you can size of the atom also, you can measure size of the nucleus also, you can measure, even you can say, I can say, mass of the electron also we can measure. Okay, even from that mass of electron to mass of sun, mass of universe, you can measure, because of, so development of devices. On the development of devices, again physics role is very much. So because of physics, we can now presently measure the mass of electron as well as mass of the universe also. Even as far as size is concerned, size of the nucleus too, size of the universe also we can measure with the help of physics laws. By using physics laws, you can measure very minute, size, like size of nucleus, to very macroscopic, very big size of the universe also you can measure with the help of physics laws. In addition to physics, some technologies also adding up, like engineering, technologies, so it is supporting to physics for all these measurements. Right? Okay, so likewise, if you don't know measurement in physics, we cannot do anything. Measurement is an integral part of physics. Okay, with all these things, I'll go now. So chapter called units and measurement. See you now. Okay, see you. So in the very first thing I'll take, the very fundamental thing is physical quantity. Let me go. What do you mean by physical quantity? Physical quantity. Physical quantity. What do you mean by physical quantity? Remember, any quantity, anything which we can measure, in presence of a individual or in the absence of individual, anything we measure, that anything will be a physical quantity. Like for example, I want to measure the breadth of this room, size of this room, I mean length of this room. So I'll take a scale. In presence of me, I am taking scale, I am finding the length of this room. I am presence here with the, scale, I'm measuring the length of this room. My presence is there. This is a direct method of measurement of length. Like even I can measure a mass, like 10 kg sugar or 20 kg sugar I can measure, like using, by taking a digital balance or by taking a physical balance, I can measure 10 kg sugar. I can measure in presence of me with a device called digital balance. I can, in presence of me, I can measure the mass of a physical quantity. This is called direct method of measurement. When an individual is present with a one instrument, if it is like an example of measuring the length, we take scale; measuring the mass, we take physical balance; like measuring temperature, we take thermometer. With a device in the presence of individual, if anything, if you measure, that is a direct method of measurement. And even with the help of physics laws, we can even measure the distance between earth and sun also. We can measure the distance between, like, even diameter of the sun also. You can measure diameter of the earth also. Like, while measuring the distance between earth and sun, you cannot go with scale from earth to sun. You cannot directly, your presence is not there, but still you know the distance between earth and sun. You cannot go to the sun for measurement of diameter of the sun. Still we know the diameter of the sun with the help of physics. Later we will come to know that diameter of the sun, we know it, that we have measured the diameter of the sun. Okay, that diameter of the sun we have measured indirectly with the help of physics principles, laws. We have measured even diameter of the sun also. Likewise, somewhere we present with an instrument, we measure directly. Somewhere we absent, with the help of physics laws, we can measure indirectly some quantities. Right or not? So what is physical quantities? The quantities which we can measure directly or indirectly, those quantities we call it is physical quantities. What do you mean by here physical quantities? Quantities, quantities, quantities which can be measured directly or indirectly by using physics laws. Quantities which can be measured directly or indirectly are called physical quantities. Physical quantities, right, are called physical quantities. Anything we can measure. It may be, example you can take here, mass, anything, whatever you can do, speed, and so on, like even temperature, right, etc. Whatever, right? They are physical. Some are non-physical quantities are also. We are nothing to do with that. Just highlight, like you can say beauty of Taj Mahal. How more beauty, how less beauty. That beauty you cannot measure it. Like smile, laughing, emotion. Okay or not? You cannot measure those things. They cannot be quantified. They cannot be given number, like beauty, like uh, all these things I can say. Okay, like measurement of a tower, measurement of a city. Measurement of city is a meaningless. Measurement of what of that city, measurement of what of tower, is it height of tower, breadth of tower? Okay or not? Like, I mean, so some physical quantity cannot be measured. I told you it's a, like all these beauty and emotions, like all these things cannot be measured. Those quantity are called non-physical quantity. We are nothing to do with that, so I'm not going for it. We want physical quantity. So all the physics formulas, laws and all, they are in terms of physical quantities, right? Okay, I'll move on. See you now. After this, I'll take now measurement process. Let me take next here measurement process. Measurement process. Okay, measurement process. I'll take this now. Okay, see here, measurement process. See here, anything you want to measure, anything, you need first unit. For example, suppose if I am go to shop, if I ask him sugar, if I ask him sugar, he will reply how much sugar. Then I have to tell, like, suppose 20 kg sugar I want, 20 kg, right or not? If I said 20 kg sugar, then he will take 1 kg unit, 1 kg standard amount, 1 kg, 1 kg standard amount of mass is what you say, it is 1 kg. Particular mass we defined, that scientists, that intelligent minds have defined particular mass as a 1 kg. So that shop owner will take 1 kg and he will measure 20 times 1 kg and that will become 20 kg, right on. 1 kg, it will be 20 times of what is a basic here size, fundamental size here, 1 kg. If we want 20 kg sugar, then what he will do, 20 times kg he will make up. Getting my point? 20 times kg. If you are going for measuring the length, we need to have meter. Meter is a unit of length. Meter is a standard amount of length. That particular amount of length has been chosen as standard. Like this much, this is called what we meter. The particular length has been chosen as standard. That is we call meter. That is what you call meter. So here meter is a unit. You want to measure like one particular length, you need to have a meter scale. Then you can measure this length is 10 times meter, I mean 10 meter. Likewise, so measurement process, anything if you measure, first thing you want unit. Unit. If you are measuring mass, you want kg. If you are measuring temperature, you want Kelvin idea. You want Kelvin, right? If you are measuring current, you need to have an idea of 1 ampere. 1 ampere is a unit, ampere. Any physical quantity you are measuring, there you need to know its unit. If you know unit, the next thing is how many times that unit is involved. For example, you are measuring 10 meter. There 10 meter is a particular length. You have chosen 1 meter scale, then you have measured 10 times. Then the length becomes 10 meter. Right? So likewise, whichever physical quantity you are measuring, you need to have unit. You need to have unit. Right or not? Whichever quantity you are measuring, you need to have unit. The next thing is how many times that unit is involved in that measurement. For example, 10 kg. Unit is kg. How many times that kg is involved in that 10 kg? 10 times kg is involved in that 10 kg. Suppose you are measuring one particular, for now, suppose I am running from one part to another part. I am running from like a 100-meter runner. He is running from one part to target, 100 meter. Right or not? To measure the time he takes, you need to have an idea about 1 second. Then how many seconds he will take to complete that 100 meter. Though it might be a micros, like 10 to millisecond, that will be there. I'll tell you, just I'm taking standard unit of time, that is second. How many times a second is involved in that total time? Like he takes 10 second, then I could say 10 times a second is involved to make up that complete time. That's the reason I tell you measurement process requires, it requires, measurement process requires first thing, what is first thing? Unit of the physical quantity. Unit. If you are measuring mass, you want kg, you measure like that. Unit of physical quantity. Unit of physical quantity. right? You want it. Second one we want is how many times that unit is involved in that physical quantity. How many times? How many times unit is involved? How many times unit is involved in that quantity? It means you are measuring on particular length, 10 meter we say, 10 meter. It means how many times in that 10 meter? 10 times the unit is involved. How many times unit is involved in that quantity means like 10 meter you have measured means 10 times meter is involved in particular length. So these two important requirements. One thing is you need to have a unit of that physical quantity, and second thing is you with the help of device, it may be a scale or it may be clock or it may be a physical balance, you need to measure how many times that unit is present in that total quantity, right? Total quantity it may be 10 kg. 10 kg are measured with the instrument. 10 is a 10 times kg is involved in the total quantity called 10 kg. Likewise, right? Okay. Now see here. See here. Now let me take that. See here. Suppose measured quantity, how do you express measured quantity? Measured quantity. How do you express that measured quantity? Measured quantity of any physical quantity. Measured quantity. Measured quantity, like measured quantity of any physical quantity. Okay. Measured value also you say. Measured value of physical. How do you express it? I'll tell you, n into u. What is n here? Let me take here in side here example. Anything you have measured, suppose a particular mass, like quantity is mass here, physical quantity is mass here, physical quantity is mass here. How much? Let me say 10 kg. Here 10 is what number, kg is what unit, kg is what unit. So any measured value of physical quantity is equals to n into u, where n is a number associated with that measurement. Number associated with that measurement. Let me take the quantity as q is equals to n into u. N is a number associated with measurement and u is a unit, right? Okay. Now suppose this 10 kg here is a 10 kg, like quantity is what, 10 kg. Can I write that 10 kg as even in terms of gram also? How will you write this kg as 10 to the power 3? Kilo means what? 10 to the power 3. Here is gram. 10 kg, and it can be written, you can write it here, q is equal to 10 kg. Here 10,000, no, it is 10,000 gram. Remember, quantity is same only, like 10 kg, particular amount of mass is 10 kg. Even you express in gram, quantity remains same, amount of mass remains same, but number associated when you write kg is 10, number associated when you write in gram 10,000, but quantity remains same. We are talking about same mass. So what is the meaning here? Size of kg is more than size of, like 1 kg size is more than 1 gram size, no? Definitely 1 kg size of unit right? Or 1 kg unit size amount is greater than 1 gram amount of mass, no? So therefore here, so unit size whenever more, like kg size of unit is more, number associated will be less. Number associated will be less. Here gram, size of gram is less, number associated will be more here. 10,000, no, it is. Right or not? Kg is bigger, then number associated with will be lesser. If you convert in another, like in gram, gram size is less, unit of, like unit gram is less, the number associated will be more when you express in gram. Same thing in all cases. If you write 1 meter, if you convert it into centimeter, 100 centimeter, quantity of length remains same. 1 meter only, particular length only, quantity of length. Even you express in centimeter, number changes, but quantity is that only. What I mean here, when size of unit is more, number associated will be less. With that, but quantity remains same. With that, I tell you, N1, U1. U1 is a size of unit in one system. Like I am taking kg, size, unit size. Like this is kg, size of unit. N1 is number associated. If I express in other unit like gram type, like centimeter type, number will change to N2 and size will become U2. U2 is a size of unit of physical quantity. But total quantity, even you convert from one size of unit in terms of kg to gram, also gram to whatever, but quantity remains same. Quantity remains same. Getting my point? Quantity remains same. So as I told you, size of unit is more, so number associated is less. Size of unit is less, number associated is more. Therefore, I could write here number associated with any measured physical quantity is inversely proportional to size of unit. Size of unit. Getting my point? More the size of unit, bigger the size of unit, the number associated with the measured value will be less. With this, you can even tell, therefore, N1 U1 equal to N2 U2, always a constant, because you are talking about one particular physical quantity, measured value of particular physical quantity. This you need to remember, right? So this is regarding a very basic of measurement, right? Okay, now from this, I'll move on to here now. Now, so we have plenty of physical quantity in physics, in different branches of physics. We have many physical quantities. Out of all those many, now we classify, right? Some are fundamental quantities, some are derived quantities. Let me one by one I tell you. Physical quantities are classified into two classes. One are fundamental physical quantities and another belongs to derived physical quantities. Let me take step by step here. Physical quantities, physical quantities are classified into two class. One is fundamental physical quantities, then second is derived physical quantities, like that. We'll take step by step now. See here now. First, fundamental. Fundamental quantities are those they cannot be written in terms of other. Fundamental quantities are those they cannot be expressed in terms of other quantities. For example, if you take here, suppose you take mass. Mass is a fundamental. So that mass you cannot resolve. Mass is the fundamental. That is only fundamental. You cannot resolve it. You cannot write that mass in terms of other. Mass is the basic physical quantity or fundamental quantity. In mechanics, we have three fundamental quantities are chosen. In mechanics, how many? Three are fundamental quantities: mass, length, and time in mechanics. Why three only? These are all, permutation combination. Scientists in the long back, they have sensed if we use mass, length, time as a fundamental, they felt all the three can cover all the physical quantity comes in mechanics. What is the meaning here? If I take mass, length, and time as a fundamental quantities, any other quantities which comes in mechanics later slowly we steadily will get enter into mechanics very soon. It's a branch of physics. In mechanics, if you consider this as a fundamental, then any other physical quantity comes in this mechanics, you can write in terms of three. Okay, I'll tell you example. In mechanics, mass, length, and time are considered as a fundamental quantity. It means these quantity are fundamental. They cannot be further resolved. They cannot be splitted into write these quantity in terms of other. They are the fundamental. Right or not? So like, let me take one example of derived quantity. What are called derived? Let me take here speed is equal to, what do you write? Distance divided by time taken. Now speed depends on distance. What is distance? Length. What is distance is what? Length. Here time. To define speed, we need length, we need time. Therefore speed here written into expressed in terms of length and time. Therefore speed is derived quantity. Speed is derived because defining process of speed in terms of length and time. Speed requires length and time to make its definition. Therefore here speed is a derived quantity in mechanics. Length and time, they cannot be resolved, for they are fundamental. What do you mean by fundamental? What do you mean by fundamental quantities? The quantities which cannot be resolved further. The quantities which cannot be resolved further. Or you can say it cannot be expressed in terms of other quantity. Physical, fundamental quantity is one. It cannot be expressed in terms of other quantities. They themselves, they are there, they cannot be expressed in terms of other, they are fundamental, they are fundamental. So in mechanics, in mechanics in mechanics, what are the quantities called fundamental? In mechanics, mass, length and time are fundamental quantities. In different branches, we'll have different level. Slowly we'll see to it. Let me complete first mechanics. Mechanics, how many fundamental quantities are chosen? Mass, length, time. So whatever, excluding mass, length, time, whatever other physical quantity comes, they can express in terms of mass, length, time. In the same way, let me write derived physical quantity, right? Derived. Okay. I'll take now derived. So here the second one is what? Derived. Derived physical quantity, right? Derived physical quantity. So derived physical quantity, as I told you in mechanics, slowly we build up, and I will go slowly different branch of the physics and their derived quantities also. First, we'll have an idea, we'll work out in mechanics. And in mechanics, mass, length, time are considered as a fundamental physical quantity, and all which comes in mechanics other than three will be a derived quantity. See here, I told you here, force is a derived quantity because force, what? Okay, let me write first what is derived quantity. The quantity which can be resolved and expressed in terms of fundamental quantity. The quantities which can be resolved, like as I given an example of speed. Speed we have resolved in terms of length and time, like that. The quantities which can be resolved and expressed in terms of fundamental quantities. Fundamental quantities. For example, let me take an example of a very simple. Let me take a force. How will you write force? Mass into acceleration. Okay, here acceleration is also a, let me write first acceleration. What is acceleration? Acceleration, we can write it as change in velocity by time taken. Okay or not? Here further velocity can be written as displacement by time taken divided by time. This can be written displacement by time square. So now displacement is a length. Here t anyhow is a time. Are both length and time are fundamental quantity. So here acceleration is expressed in terms of length and t square. Right or not? So acceleration here expressed in terms of length and time. Right? First we have converted velocity by time, then velocity displacement by time, like that. So you can say acceleration is composed of length and time. So acceleration is a derived quantity because its definition, it's a, it's a defining process involve fundamental quantities like length and time, right or not? So acceleration, you have resolved it and you have mentioned in terms of fundamental quantity. Likewise, this force also, force force is also a derived quantity because that force can also be expressed in terms of fundamental quantity. Here m is there, m is anyhow it is a fundamental. Acceleration in terms of fundamental is what? Acceleration in terms of fundamental is L by, now you think of all the three, therefore force has been expressed in terms of fundamental quantities. Like force is expressed in terms of fundamental quantities, mass, length, time. Here force is also a derived quantity. One thing you remember in especially mechanics, excluding mass, length, time, whatever physical quantity you will find it in mechanics, like it may be momentum, okay, it may be force, okay, like many whatever, like it may be uh, gravitational, like g formula, g is equal to, like capital G m by r square, like many formulas we find it in mechanics. Many physical quantities also we find it in mechanics, they are called derived, excluding only mass, length, time, excluding only mass, length, time. Like, so what is derived quantity? The quantities which can be resolved and expressed in terms of fundamental quantity, force, acceleration, like momentum, okay, like any whichever quantity you take, it may be uh, whatever formulas you find, whatever physical quantity you find other than this mass, length, time, they are called derived. You can write, in case of example, you can write speed is a derived quantity. You can write acceleration is a derived quantity. You can write force is a derived quantity. Right? You can write many, like you can take uh, many things in, especially in case of mechanics. Right? You can write momentum is a derived quantity. Momentum. Now slowly I will extend the concept to all parts of the physics. For simplicity, I have taken only mechanics. Now we'll see slowly. Okay. 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 Conclusion, in mechanics, how many mass, length, time are fundamental quantities? Other than that, we get in mechanics, they're all derived quantity. Right? Okay. Now with this, I'll slowly entering into system of units. Right? Now I'll move on. See, after this, I'll go to the next thing. Now I'll take now system of units. System of units. What is system of units? The name itself is system. When do you system means what? It's a collection of, what do you say? One particular, like I could say system means it's a collection of some one discipline, like let me take system of units. I'll tell you practically. We have fundamental quantities also have got unit, like mass, length, time, and even we have derived quantities also have got unit, like force is a derived quantity, it has got Newton. Like collection of units of fundamental as well as derived units. All these units, like fundamental quantities unit, kg, meter, second, like derived quantities units, like all these units are fundamental as well as derived. That is we call system of units. System of units. Right or not? System of units. Units of all fundamental as well as Okay, what is especially, what is unit? It might be a very like unit is what? It's a standard amount of quantity chosen as a reference for measurement. Like 1 kg is there, no? Like particular amount of mass is taken as 1 kg. That 1 kg is taken as a standard for reference of measurement of mass. Like particular length is called meter. That particular length is made as standard of, you know, a standard amount of length. That standard amount of length has given a meter length. That standard, what is unit? It is standard amount of quantity. It may be meter length as a one quantity, it may be particular mass as a quantity. What is here actually unit? Okay, I'll come to it. What is the definition? How do you define unit? What is define unit? Kg, like it may be second, kelvin, 1 kelvin, like 1 ampere. What is unit? It's a standard amount of quantity. Like meter length is 1 meter length is taken standard amount of length. 1 kg is taken standard amount of mass. 1 second standard amount of time. What is your unit? It's a standard amount of quantity. Some amount, let me amount of quantity chosen as standard also, you can say some amount of quantity, some amount of quantity, like meter, you can say quantities, like I'm talking about length. Some amount of quantity is chosen as standard reference, chosen as standard reference for measurement, for measurement. Some amount of quantity is chosen as standard reference for measurement. Particular length has been made as meter name. That meter is a standard amount of length that has been called as unit. Like standard amount of one particular mass, like is chosen as standard, that is called kg. Some particular amount of time, like 1 second, has been chosen as standard reference, that is unit of time. Likewise, this is the definition of unit. Okay, now I'll move on now here. System of units, not collection of units of fundamental as well as derived quantities. It's called system of units. Now, as you go back to history, many system of units has come and gone, but few are remembered. Even they are still running. Few system of units. Let me take first is CGS system. CGS system of units. CGS system of units. This is actually put forward in France. Okay. Here in this system, like CGS system is a one system of units. In this system, so unit of length is taken as centimeter. Unit of length in this system is centimeter. Centimeter. Like unit of mass is taken as what? Unit of mass. Unit of length is taken what? Unit of length is taken as centimeter. Unit of mass is taken what? Gram. Right? Okay, unit of this time is taken. Unit of time in this system has been taken as second. Right? Okay. These are all the fundamental, these are all the units. Unit of length is centimeter, unit of mass is gram, unit of time is second. It is CGS system of units, right? So earlier, uh, in many countries, this was the system of units was running. To measure length, they had taken centimeter. To measure mass, they had taken gram. Like that, it was running earlier. Even now also, we find it for measurement of some fundamental quantities. Okay. Okay. Now I'll move on now. Next thing is, second thing is we have MK like FPS system. I'll take second one is FPS system. FPS system. It is also called foot pound second. What is this? Is foot pound second. Foot pound second. Here, this is a British system of unit. Even in England, presently also they are using foot as a unit for measuring length, pound as measuring mass, and then second as measuring time. Even now also they are still going with this system of units. So here, foot is a unit of length. In this case, is what? Foot. Unit of length is foot. Then unit of mass is what? Unit of mass. Unit of mass is unit of mass unit of mass is, in this case, it is pound. Unit of time here, unit of time, in this system it is second. This is one system. Okay, in different system they defined different unit of fundamental quantities, right? Derived quantities will be in terms of this. If suppose FPS is there, in mechanics derived quantities will be in terms of foot, pound, second, right? Okay, this is also even presently also in different corner of country. Measure in England, this is only they are still using, right? Now in this next is MKS system. MKS system of units. It is also a French system. Okay, this is given by in it has been developed in the France. Here, this is also called meter kilogram second system. This is what? What is MKS stand for here? Meter kilogram. Then here S is second. Right? Okay. Now in this case, same thing, unit of length. Length is measured in this system with meter as a unit. Mass is measured in this system. What? Kilogram as a unit by taking kilogram. Now here, time has been measured by taking second as unit. This is one more system. But these systems, they are not extended to different branches of physics. These systems like FPS, CGS, MKS, even though they have gone to different branches of physics, there is no coherence concept. I'll tell you later. Coherence, like these are called not coherent system. I'll tell you. They are successful in defining derived quantities in mechanics. In case of like other branches of physics, they are given different quantities irrespective of whatever we have in the mechanics. They are given defined different units in different branches of physics. different units completely in different branches of physics. It's completely much disadvantages are there for these systems. Presently, all these are sidelined, though they are there off the screen. They are presently even they are also there. But as of now, these systems are being now taken to site. Now we have got SI system. We'll give more time to that SI system. Now presently we are using SI system only. Right, that SI system give an answer to all the queries. These systems have got much disadvantages. In the later classes I tell you, these systems are sidelined. In different all the countries presently, one system of units has been running. It is a SI system. Regarding this, I'll tell you in the next class. In the next class I'll start SI system of units. Right. Thank you, students.